Yeah, we're gonna go with number one. We're gonna solve the first equations. Uh, I'm pretty sure you know all the answers. 6x plus 3 equal 2x plus 11.
Minus 11 from.
Yeah, but let's go and say that solving those it's linear equations. So we don't have a quadratic equations where you have power 2. You don't have a rational equations where you have a variable in the denominator. You don't have a radical equations where you have a square root or something. It's simply linear. And you must understand linear before we move to the next level. So linear, we isolate the x terms, we put all them on one side and all the constant terms to the other side. So you're gonna subtract what?
2x? No.
Yeah, 2x is good.
You can, but.
Yeah, you can do that.
Yeah, it doesn't matter.
It doesn't matter what. It doesn't matter you put an x on the left or on the right, okay?
Yeah.
So that gives you
4x plus 3 equals 11.
equals 11.
Minus 3 from both sides.
Minus 3 from both sides.
4x equals 8.
4x equals 8.
Divide by 4.
Divide by 4.
X equals 2.
X equals 2. This is the answer. Answer is not the solutions. It's my still not working. That's why I said, oh, go back and try to plug 2 in the original equations. If the left equal the right, then it's true. Okay, 6 times 2 is 12 plus 3, 15. 2 times 2 is 4 plus 11, 15. Now, we like to state the solutions. We said the solution is 2. We put it in parentheses like this, all right? So S, we call it S. Now, I'm pretty sure everyone can do the next one because when you solve equations, there are three possibilities, three possible outcomes. Either it's conditional, that means when you solve the equations, you find x equals something or y equals something. It would be equal 0 or negative number or positive number or fractions or decimal, but it would equal to something. That's conditionals. And you have identity. It's like when you try to bring all your x term to one side, you cancel it, all right? Then there will be indefinitely many solutions. That's something you do in high school, right? And then you have contradictions. Is when you try to solve the equations. What happened? You cancel x from both sides. There is no x, but you have like 2 equal 5, negative 2 equal negative 5. So that would be no solution. So let's try to do all three at the same times. When you have conditional solutions, like solve 2x. I go back to 2x again. I don't know. Let's talk another one. 3. 5 minus 1 equal 4. Okay. X plus 2. Okay. Let's solve this one. What are you gonna have?
Distributive property first.
Okay, distributive property. I agree.
15x minus 3
15x minus 3
equals 4x plus 8.
4x plus 8.
And then you minus 8 from both sides. Or you can minus 4.
Minus 4 from both sides. Yeah.
11x
11x
minus 3
minus 3 equal 8.
plus 3 to both sides.
Plus 3 for both sides.
11x equals 11.
You cut down, I just take a random one and x would be 1. X equal 1. So this is the answer. I'm pretty sure if you plug it's gonna be the same, so we can conclude that the solution is 1, right? This is conditional because when we solve, we find something for x. Is that correct?
Yeah.
Let's see contradictions. Let's go identity first. Identity. Okay? If I ask you to solve, take something random from my big head. Let's go and do 5x minus 2, 4x plus 3 equal, negative 3x minus 2. Okay? If we ask you to solve something like that, tell me what you're gonna get if you need to solve something like that.
You're always going to want to do distributive property first.
Distributive property first.
So if 5x minus 8x
5x minus 8x
minus 6
minus 6.
equals
Okay, I need to put this one plus, sorry. Yeah.
equals negative 3x
Negative 3x
minus 6.
minus 6.
Now it's just about you combine like terms now.
Yes, combine like terms, that's the next step.
Negative 3x
Negative 3x
minus 6
minus 6.
equals negative 3x minus 6.
Uh-huh.
And now you just do what we've been doing. Add 6 to both sides.
Add 6 to both sides.
Yeah. Negative 3x equals negative 3x.
Uh-huh.
And now, oh.
You see? Left side equal right side. Now if I try to move all my x's to one side, guess what's gonna happen? Look.
We just, and in this case, it's just going to be 0.
0 equals to 0. Because left side equal right side, we said there are indefinitely many solutions, So we said there are indefinitely many solutions. And usually, how we represent this, we just say S equal a beautiful R. We said indefinitely many solutions. Or you said it's all real numbers. Do you know that? Solutions? I'm going to write it all real numbers. Or you can say S solutions, all real number solutions. All real numbers. Okay? Solutions, all real numbers. So let's say this is your next one. We said it's conditional when you solve, you find something. It's an identity when you try to solve and combine like terms. Put the x's, isolate the x's on one side, the constant term on the other side. When you try to do that, you end up cancel everything, but except the left side equal the right side. Now, let's try to do another one. That we call this one contradiction. Okay, contradiction. Contradiction, solve. We have, I promise I'm not gonna take 2, so 7x minus 1 plus 8. Okay, equal to 3x plus 1, okay, plus 4x minus 2. I'm gonna try it now. 4x plus 6. I'm gonna give you something like that, right? Now let's try this one. We're gonna try it. We're gonna try it. 7x minus 7, yes. Plus 8.
Equals 3x plus 3.
Plus 3.
Yes. Plus 4x plus 6.
Plus 4x plus 6. Now, next step is
Like terms.
like terms. Combine like terms.
7x plus 1.
Plus 1.
Equals 12. No, 7x plus 9.
Plus 9.
And then just solve from there.
Okay, I subtract 7x both sides. What I have left?
1 equals 9.
Is it true?
No.
No, 1 is not equal 9. If you are 1 years old, you are 1 years old.
Right.
Whoever is 1 years old is not 9. It doesn't mean 9 years old, right? Of course not. Okay, so because the left side is not equal to the right side, you said there is no solutions, all right? So no solutions. Oh, usually we said that's false. That's a different way of saying it. When we find 0 equal to 0 in the other side, we could say that's true. Okay, so no solution. So we can leave it like this as the answer. So anytime you're gonna solve any equations, there would be 3 possible outcomes. You have a solution, there is no solutions, okay? Or you have indefinitely many solutions, all right? So 3 possible outcomes. Of course, later we're gonna talk about imaginary numbers. That should be something different. We might have a solution that is, complex solutions. That could be complex, all right? So, but we're gonna see that later, okay?